When computing probabilities that are based on observed frequencies, it's a good idea to set up a frequency distribution to organize the information, and that's what we're being asked to do here. We have a 2-pound bag of Hershey's miniatures, and we have a breakdown of all the different types of candies inside. This is just 2 pounds of absolute delightfulness. To set up a frequency distribution, we'll set up 2 columns. The first column we'll label the results, the possible results of a of a probability experiment, and we'll call those the classes. And then the second column will be the observed frequency of each of those results. Now, our first result listed is there are 33 milk chocolate bars, which are a little dull, but perfectly fine. They're better than, say, spinach. Next, crackle bars, where they mix in some puffed rice. Fantastic stuff. There's 27 of those. There are 26 Mr. Good bars, for those peanut fans out there. And this is an absolute gyp, the best of all, the dark chocolates, there are only 19. What's that about? Now, what we're going to want to do is total up all of the possibilities to help us compute our probabilities. So we get 10, 16, 19 is 25, 5, 7, 9, 10. There's 105 chocolate bars in there total. Now we can start to compute probabilities because we have all the information we need. Question A, probability of getting a Mr. Good bar. That's a direct probability calculation. 26 of the outcomes satisfy that event out of the 105 total. This time around, because the fractions are a little bit awkward, it seems reasonable to go with decimal equivalents, and this probability works out to be about 0.248. Question B, crackle or special dark. Well, for that, we're going to add 27 plus 19, meaning there are 46 outcomes that satisfy the event of being either crackle or special dark out of the 105 possible outcomes. And as a decimal, that is about 0.438. Finally, for C, not a milk chocolate bar. Here's another one where using complements is a good idea. There are 33 that are milk chocolate bars. So that's the probability of getting milk chocolate. Not getting milk chocolate is 1 minus that, which is 105 over 105 minus 33 over 105, which works out to be 72 over 105. And in decimal form, that is about 0.686.